Hello, hello. All right, I am using the microphone mainly because it's being recorded, and if I don't use the microphone, then the recording will have nothing in it. Okay. One second. All right. So thank you everybody for making time to come here tonight. This is the brand new office for Cash App and a brand new office in Melbourne. And so welcome everybody to Cash App. Hope you had a chance to meet some new people and have a good chat. So this is the very first meetup of any kind that's being held at this location. So hopefully it all goes well. And if you have any particular feedback, we would love to hear it. So, wow, that took ages. So back in the summer of early 2018, I was working for a startup doing Scala, but I was on Christmas holidays and I wanted to do something constructive with my time. And I had a couple of interests that seemed to come together at that time. So the first thing was I had wondered for more than a decade, what would it be like to build an open source product that people could actually use and would be useful, something substantial. And at the same time, there was cryptocurrency mania going on, as there still is to some degree. So I had been interested in Bitcoin for a long time and tried some early mining, but unfortunately didn't persist. And I thought that what I would do is I would look for a crypto project that I could invest my time in and get to really know something well. And Bitcoin was the first thing that I wanted to do, but I felt that it was too mature. I wanted something that I could get my hands into while the Christmas holidays were still going. So I, in the context of the flurry of projects that were happening in the boom of late 2017, I trawled through a few of them, and when I came across Stella and I looked at what their purpose was, I thought this is something that really matched my principles. So I dove into that. So tonight I'm going to be talking about that project that I started and that I'm still working on. And I'll start with some background about what Stella actually is. And then I'll be discussing the project itself, some things that I'm proud of and some things that didn't go quite so well. So for context, imagine you're from Mexico and you're working in the US. Your work gives you the opportunity to provide for your family living back home. You've probably all heard by now that remittances from the US back to South America are a big deal. In Mexico, about $26 billion a year is remitted. And that is, let me check that number is right. Yeah, that number is 2.5% of the Mexican GDP. And that money pretty much goes a long way to the families back home that are sometimes living in stagnant or just completely stopped economies, slowing economies. In other South American countries, it's much higher impact. So El Salvador and Honduras, for example, have about 15% of their GDP remitted. Now, the traditional companies that do this, companies like MoneyGram and Western Union, charge on average about 4.4% to do it and take about 3 to 5 days. So the promise of Stella, which wants to bring financial freedom to this kind of cohort throughout the world, is that you could do these transfers on a network in a generic way for a fraction of the cost and a fraction of the speed. So the underlying network will take 5 seconds to do a transfer instead of 5 days and will cost fractions of a cent, like many, many fractions of a cent. This guy about to come up now is Marco, and he has a company called Saldo. He's one example of a company that's built on Stella. His app, Saldo, allows migrant workers to directly pay bills back in Mexico. So Saldo looks after the remittance, it looks after the multi-currency conversion and the paying of the bill as well. So using the Stellar network means that making these very frequent small remittances is cheap and fast. And one of the interesting things for me, and something I'll come back to a few times, is that no permission was needed for him to do so. The network is open access, and if you want to build on it, you just build on it. And no one actually has the ability to stop you from building on the network. And there are very large companies using it too. So Franklin Templeton is a super big investment firm, a New York Stock Exchange listed, 70-year-old company with $717 billion of assets under management. They announced via a submission to the SEC about 6 months ago that they would be using the Stellar network for, let's get the wording right, as a public immutable system of record for their government securities mutual fund. So this is not anything to do with cryptocurrency speculation, which is what you might have in your mind because I'm talking about cryptocurrency. It's not about speculation or trading or any of that sort of stuff. It's about using the infrastructure, the public infrastructure, to have a trusted system of record of who holds what. And this is the first instance of a mutual fund using a blockchain for this purpose. So I read. And Stellar is a very good fit for this purpose because it has at its heart the concept of asset tokenization. That is, you create on the ledger virtual tokens for things that represent value in the real world. Franklin Templeton said just quickly that they plan to move all of their mutual fund record keeping to Stellar in the future. So interestingly, I had a slide here that was about a deal that just fell through yesterday. So a quick change. It's not just financial instruments that are being represented. People are using it for all kinds of things. So there's an app called Pigsby, which comes with a little pink device that children use to do chores in exchange for a currency called Wallow, which can then be traded on a decentralized exchange. There's a company called Upvest, which actually uses the Scala SDK that does real estate tokenization, so you can buy a portion of a property for investment purposes. Smartlands does as well. That's a more famous one. It also does precious metals and other asset tokenization. Bitbond tokenizes bonds and real estate. IBM, Big Blue, uses Stellar as the foundation of their multi-currency payments platform called WorldWire. And the London Football Exchange bought 80% of Perth Glory, the A-League club, with the idea of tokenizing equity directly to the fans. That's the one that didn't make it. So Stellar can be a suitable platform for all of these purposes. It's resilient, it's permissionless, it is decentralized in a different way to Bitcoin, and we can talk about that after. I don't cover consensus models too much and no discovery and that kind of stuff, but it is really interesting and I'm prepared to talk about it. And so any fungible thing, be it money or other cryptocurrencies like Bitcoin or equity or credit, can and is being tokenized on this system. And the global reach of the network goes a long way towards reducing the friction inherent in cross-border transactions. The current financial system is too costly and complicated for most people. And what Stellar aims to do is to provide the infrastructure that allows people to transfer that value easily. Let's talk a little bit about how things are modeled. Who likes Flight of the Conchords? Oh, I love them. In Stellar, one of the primary models is accounts. So here I'm showing 3 accounts, one for Murray, one for Jermaine, one for Brett. And then each account has a number of balances in different assets. So for example, Murray has New Zealand dollars and Bitcoin, and not much of either, unfortunately. In Stellar, what you do is you you compose modifications to the ledger by writing operations, wrapping them in a transaction. It's not a payment transaction sense, it's a atomicity transaction sense. And then you submit that to a node, which may or may not get accepted. Let's run through it, we'll see it happen. So in this example, Murray is going to pay the other two some money. He uses his phone, which has an SDK on it, to write and encode a transaction that has a payment operation to Brett, another one to Jermaine. He signs it with his private key. And at this stage, the transaction is a blob that he could email to somebody if he wants to. He could write it down on paper, keep it for another time. But he uses the SDK to transmit it to a node. When this happens, the node performs some validation. And if accepted, then the node includes it in a gossipy conversation with nearby nodes for inclusion. And as a group, all of the nodes, through federated Byzantine agreement, decide what's in and what's out. And as a consequence, everything is updated at the same time. So one big distinction between federated Byzantine agreement and the Nakamoto protocol, which Bitcoin uses, is that Bitcoin, because it's very much market-driven to get the extreme level of trustlessness, has the property that you might look at some rare occasions at different nodes and see different versions of the truth. And so that's called liveness, because it always keeps going and it's consistent eventually, rather quickly. Stellar, on the other hand, doesn't have liveness, it has safety. Whenever you look at a node, it will have the truth that's the same throughout the network. But that comes at a cost of, if the nodes can't agree, then the network stops. So we saw in the previous example that the accounts had balances in US dollar, Bitcoin, and New Zealand dollar. And so as part of the network's open access, anybody in this room or anybody in the world can issue their own account and even use those same asset codes. I could issue a US dollar and have it be backed by bananas or nothing. So what actually ensures that an asset on Stellar represents something of value? The key is that they have to mirror things that are in the real world or on other networks. And account holders are known and public entities, account holders who are known and public entities who perform this function of taking deposits and issuing tokens are called anchors. So anchors undertake to receive real-world value and issue tokens on the network. And in response, they do the reverse. When they receive tokens, they'll destroy them and redeem the value back to the account holder. For example, Cowrie Exchange is an anchor for the Nigerian currency Naira, and they have a token called NGNT. If you deposit Naira with Cowrie Exchange, they will give you NGNT tokens on the Stellar network. And for as long as Cowrie is trusted by people to perform that function and perform the redemption in reverse, then it can be considered that NGNT is one-to-one equivalent in value with the Naira. We are getting to the Scala stuff soon. Hang in there. That really means that once you have NGNT token on the network, you can trade on network for other things. So you could use your NGNT to buy US dollars or Bitcoin and then redeem those. So what I find really great about this system is that anchors don't actually have a privileged position. They're actually clients of the network just like anybody else. And they all access the network through a... I'm just reading my notes, one sec. So this is the network here, and the nodes are instances of software called Core. And Core's responsibility is to make sure that consensus happens quickly and efficiently. And as a result, it's not very good at providing information to clients of Core. So we have another system in the middle with the red box here called Horizon. Its job is to ingest information from Core and then present it in a fashion to the clients so that they can make business decisions in real time. Horizon is also the bridge through which transactions pass. To make it easier to work with Horizon, there are SDKs, and there are SDKs in Java, JavaScript, Go, C++, C#, Python, Ruby, some other stuff, and now Scala. So, back to the beginning. Back in 2018, I took on the task of building the SDK. I had 3 motivations. I wanted to build something useful. I wanted to practice Scala beyond the Spark that I was doing in my day job. And I wanted to learn enough about Stella to be dangerous, or at least helpful. To get started in this task, I decided to rewrite the functionality of the already mature Java SDK. And I plan to rewrite it rather than just wrapping it, because that would teach me nothing, or transposing it. By taking the functionality of the existing Java SDK and rewriting it, I really hope to come to understand the finer details of the Stellar network and of Horizon. And by ensuring that I rewrote it in idiomatic Scala and not just transposing it, I had hoped that I would build an API that would be a joy to use. So 2 objectives. The first one I met, and the second one, not so much. Going through the Java SDK and replicating the functionality was a great way to get a living functional requirements document. I knew exactly what the previous authors cared about. And working through the features, I found myself quite often nodding along with what I saw, but sometimes a little bit perplexed. And I'd have to shut the laptop down and go out and walk my dog. And then it would come to me, oh yes, I understand now. And it would deepen my knowledge a bit. So I kind of discovered that that was the way that I learn best. As I mentioned, I was hoping to build a joyful API. And I know Scala's APIs can be much better than Java's API, so I wasn't going to copy what I was seeing. But I was starting from a place where I didn't know what I wanted to build. And I had this misconception. I thought that because Scala is very expressive, I could just do expressive Scala from the inside out, let it percolate up, and it would be beautiful. Not a chance, no, it's not like that. Good API design takes a lot of work, and you should always be putting the customer first and going from the outside in. Here's an example. So this value here is one of the 13 operations that I mentioned previously, the operations that append to the new state to the ledger. This is a multi-currency payment. It's a path payment strict receive, which means we will send some variable amount in one asset, and the recipient will receive an exact amount. It specifies the maximum amount of, in this case, Bitcoin that I'm prepared to send, the person who will receive it, the exact amount that they should receive, and any intermediate assets that this should trade through in order to get there. So there may not be an order book directly between Bitcoin and New Zealand dollars. I might have to choose another asset to trade with. To state this in plain speak, this says, without spending more than 1 Bitcoin, trade Bitcoin for some quantity of the native asset. And with that quantity of the native asset, trade it for exactly 14,800 New Zealand dollars, and then give those New Zealand dollars to Jermaine. Maybe this is a better way to have expressed it as a DSL. So this expression here, which I imagine and haven't actually built, is saying that I want an upper limit on the amount. I want to go via this to exactly that amount and pay to this person. And what I'm doing there in the types is, in my imagination, is constructing a strict receive, whatever it was called. I forget the operation name. A path payment strict receive operation. I think this is better. You might have a different opinion. I would like to do this work soon, but I still don't actually have any guarantee that this is what a client would want to see, want to write. And so the best way to answer that question is actually to gather feedback from users. So whilst the SDK has feedback from users, and has users, actually has a business user that I know of, doesn't have too many, and feedback's been really hard to gather. So I tried Gitter. Gitter is, if people know what it is, it's quite a popular chat tool that you attach to projects, and then people can jump on and say, I've got a problem, help me fix it. Totally useless. It's useless when I use it. I ask questions and nobody answers. It's IRC all over again. And in my Gitter, there's a few people there and nobody talks. So there's no community. Oh, well. So the second best thing, I think, is to build an integration test suite where I can try to play the role of a client myself. So the way that I've done it in my SDK is, I think, a bit unique amongst the SDKs. There's a public test network that the other SDKs seem to use, but there are some operations that you need to have known state and fixtures to be able to get assertions that you can rely upon. And so what I do is I fire up a local Scala network using Docker. Let me click through it. Now I just pipe that out to a shell script. I only ever work on the Mac. I run my builds on Linux. If I ever had to build on Windows, I'd have to deal with that. There's probably an SBT plugin that does Docker stuff. I don't need to worry about it, so I didn't do it. In my API design, I've made networks implicit because they're passed through to some of the functions, and I didn't want to be too verbose. Not sure whether that was a great idea, but I fire up the standalone network just by passing through an endpoint, and then I can run my fixtures through. This goes down another few hundred lines, and then I've got a bunch of tests underneath. Yeah, so by working with a fresh network every time, I've got some deterministic state that I can run my assertions against. A great thing about writing a test like that is that you can generate sample code for the documentation. So many of you probably know the Lightbend project Paradox does great things for transforming Markdown in your project to HTML documentation. I use that and pipe the documentation up to GitHub pages. It does stuff like validating that links you have to Scala doc are classes that actually exist. And will fail your build if that kind of stuff is wrong. And one of the great things you can do is you can demarcate a block of code, as I have here with hash payment example, and reference that in your Markdown, and that will appear as documentation. And it gives you the guarantee that the code that you document in your documentation is something that actually works against the version of the software that you're publishing. But I'm a huge fan of unit testing. I think unit testing is really important to fill the gap between the capabilities of your static type system, so compiler does testing, and the huge range of values in your types that may hold hidden surprises. So I wanted to get as close to 100% coverage as possible. I realized that aiming for 100% coverage in a project that already exists is a way to shoot yourself in the foot, because you end up building tests that convolute themselves around the designs that you've made in your code. But by starting at close to 100% from the beginning and maintaining that all the way through, a bit slower to build things, but I think it's helped me make a really cohesive design and good abstractions. As of today, the project is at 99.91%, and I'm not a perfectionist, so that's it, that's good enough. Of course, I'm not complaining that the README badge rounds up. One of the second goals that I had with the testing was to rely on Scala checks. Scala checks been covered in this group before. I love it so much. Property-based testing is amazing. So again, it's this theme of exploring the gap between your type system and all the values within a type that may cause you problems. And pretty much every time I've used it, I've found values that give unexpected results. And I particularly like that because the gen type composes monadically that you can use for expressions to make really complicated arbitrary values at runtime. So here we're using the built-in gen choose to give us a random number between min and max, wrapped in a method that takes from a stream of random alphanumeric characters to come up with an arbitrary string, which will be an asset code. That then is mapped with another generator that gives a asymmetric key pair, which is the foundation of how you prove what assets you own on the network. And I guess an important point to note there is that, excuse me, an asset is a combination of somebody's account and a code. And then that itself can be used to generate an amount, which requires an asset and a positive value. And that as well can be used to generate a payment operation, which is an amount, a destination, and possibly a source, because I won't get into that, but you can, I was about to get into it. I'm not going to get into it. Yeah, so at test time, with this implicit arbitrary value, here with the property key, the prop keyword, what we're getting is execution of this code block, I think 100 times, with arbitrary values of payment operations using all of those nested generators. And the property that I'm testing, so one of the key things with property-based testing is you don't have explicit values that you can do assertions on. You can only test properties of the values that you have. So this is, I think, a good property-based test. It's to say that when I serialize a payment operation and then deserialize it again, I should get back exactly what I started with. So speaking of serialization, the Scala Development Foundation decided that they would serialize all of the types that are internal to their system using a scheme that's a bit like protobuf, but much older. It's called Extensible Data Representation, and it was devised by Sun in the 80s. What you see here is a couple of examples of how you would define a type. And the approach that most SDKs and the core software takes is to use a parser to generate code, which is then copied in and compiled. This is some of the Java code that's generated that matches that definition. I jumped into the parser that they use, which is a Ruby project, and struggled and managed to get it to generate Scala source, and then threw it all away because what happens is, and what you see in the Java SDK is, the XDR model for the types does not match the types that you want to show the user. Because they have discriminators and other things, they're far too nested with things that don't make much sense, and you need to use mutable builders and what have you. So you end up with a user-facing model and then having to write some bridge code through to the automated generated code. It's a lot of work. But what you do get with that approach is you get some certainty that the generated code is correct. I decided to take a different approach, and that is quite simply to build a little DSL that knows how to construct the primitive types. For example, here, an XDR integer is defined as 4 bytes. A sequence of bytes is defined as the length as an integer followed by those bytes. A padded byte array is in multiples of 4. And a string sits inside a padded byte array. So they've all built on top of each other, and they're the primitives. And with those primitives, any type that needs to be encoded, I can easily just concatenate these sub-encodings together. For example, a public key starts with a discriminator and the bytes of the public key. And a create account operation has a discriminator, a public key, and the starting balance for the new account. So encoding is pretty easy. For decoding, I had a kind of funny problem that imperative programmers wouldn't call a problem, but I didn't want to have loopy code or mutable state anywhere in the SDK. So I turned to this group here for advice, and I'm not sure who gave me the good advice. Might have been Chris, might have been Ben, not sure, but it was to use the state monad. The problem is this, how can I transform this stream of bytes that represents an operation of some kind, byte by byte, building up the object whilst also keeping track of the bytes that are not yet read? For example, the discriminator, I know it's a create account operation. I'm trying to form a key. There's another discriminator. Oh, it's a public key. There's the public key bytes. There's the starting balance. The answer was the the state monad. So it's a little machine that probably, I'm talking to you before, most of you are hardcore functional programmers, you know all about it. For those who are not, it's a type, which is a tiny machine, which will allow you to run it with an initial state, and it will return two things. One is the result of a function run over that initial state, but also the state transformed after having the function run on it. Does that sound right? Yeah, thanks, Ben. So again, by defining primitives for the decoders like int and bytes as state monads, I can then use them to use for expressions with them to compose more complex decoders for things like a public key and a create account operation. And executing it looks a little bit like this. When we tell the decoder to run with the encoded value and then get the value back out of it, we have a tuple, which is the bytes remaining to be read and the value decoded. So the Stellar community comes up with ecosystem proposals, ways to make life easier for participants on the network all the time. And these are some of the most fun things to be able to implement. There's a thing called a brain wallet, which is a mnemonic phrase which is used with a codec to come down to a seed, a large number, which can then be used to form your private key. So for example, here, from a word list, I think it's 4,096 words, I can get a random bunch of words that represent indexes into that list, which put them all together represents a number. And there's support for multiple languages. There's 4 languages at the moment. There's more languages to be supported still. And then from this, you can use that root seed to get something called a hierarchical deterministic node. So this is a really interesting structure that both of these came out of the Bitcoin world initially as improvements to Bitcoin. An HD node is a secret seed from which you can generate a tree, a limitless tree of other seeds. And each seed can be converted into a key pair to be able to identify a count. So this, let's see it in action. So this is from the root node going down and finding other nodes. 44148 is by convention the namespace for Stellar keys. So then I go to the root node, go to the 9.8 millionth node, then the 32 node, 5 levels deep, and decide to get that as a key pair. And this is what it comes back as here. Interesting side note, you'll see that the secret seed, when printed out, is obfuscated. For obvious reasons, you don't want that appearing in log files. So this is pretty useful for accessing a lot of addresses using just one secret. And I think it's probably good for rotating addresses as well. You can, looking at you, Miles, yeah, you can use it for that. Good stuff. And they're great ways for generating private keys, but public keys are problematic also. We saw a public key previously, and it was pretty hard to remember. It'd be good to have a way to alias public keys, and Stella has a scheme for that called federated addresses. So we have an example of address here on the fourth line, which is Gemstar Keybase IO. If you are a Keybase user, you have a Stellar account, and your account's federated address will be your username star Keybase IO. The way we get that is we look up the domain info. This is a network call on line 2. Got more animations, so why don't I use them? And that goes to a well-known location to get a config file that may point to a federation server. This call will construct, it's not just a string, it will construct a federation server client. And with that client, you can ask the server to try to resolve that name. So it's not just simple names. You can use it to resolve things like email addresses, Twitter handles, phone numbers. The way that this is really useful is that you can actually send a payment to an account that doesn't exist yet. And the federation server or some service related to it might have the responsibility of saying, let's email or tweet that person, let them know that they have money waiting. Then in a viral sense, they get sort of invited to join the network and get their money or whatever it is. Perth Glory, equity, perhaps. So writing this project continues to be a lot of fun, but there are certainly some aspects that I found difficult. Publishing artifacts. Publishing to Maven Central is so terrible that there's a whole industry blogging about it. And I just skipped right over it because I've done it before and I'm not going anywhere near it. I went straight to BinTray, and that was still pretty hard. I had complex SBT plugins, I had key management issues, and every time I tried to do a release, I had to remember, where did I put the notes about how to do this? It involved manual clicking through into BinTray and 5 levels deep and then pressing a button and waiting an hour. Sorry, I've gone ahead too much. Then I moved on to Jitpack. If you haven't heard of Jitpack, it does this interesting thing that's obvious in hindsight. It looks at the tagged releases for on a GitHub page and just does a SBT publish or package, SBT package, and there's your package and it will post it for you. That's what I'm currently using. GitHub has just released its own packages stuff, and there's an SBT plugin for it, and I'm keen to dive into that and see how well that works. Futures and Akka in the API. So I have a lot of network I/O methods, and I thought the right way to deal with that is with futures. And this is the #1 reason why I haven't talked about this. Talked about the SDK to a lot of people, because it makes snippets of how to use it look too complex. I think, and correct me if you have a different opinion, but I think blocking methods in the API in a core module with supplementary modules that support different maybe functional programming libraries that people can bring in if they want those, that type of treatment is probably a good way to go about it. But then again, maybe I've done the right thing. Maybe futures is right. Not sure. And Akka in the API. So I wanted to, part of the Horizon API uses service-end events, and I wanted a good streaming library for that. I brought in Akka. I used Akka HTTP, which was too much extra complexity. And I just had Akka sitting in a library API. I just felt it didn't need to be there. And I have since stripped that out. I've replaced the HTTP layer with OK HTTP, which is a Square project. And that's worked much better in terms of cleaning up the code. And the idea is there that I'd have an Akka module that people could use if they wanted it. What else have I got? Versioning. So this is not about versioning of the SDK. This is about versioning of Horizon. So I have not yet built a way for the SDK to look at the version of Horizon that's being used and then form the requests properly. That's That's a piece of work that I haven't tackled yet. And so what the state that I'm in is when a new version of Horizon is released, I release a new version of the SDK. People who are running their own private network on an old version of Horizon don't have any upgrade path. So I'm not supporting them. But those people may not exist because I don't have contact with the users. Hopefully they will raise an issue if it is a problem for them. And also versioning of Scala. So we went from 2.12 to 2.13. I wanted to cross-compile. I thought it would be easy. I spent quite a few hours upgrading all of the collections types. Then I tried to add the shim that would make those new collection types work on 2.12 and cross-compile, and it didn't break, but it didn't work either, and I haven't solved that problem yet. Be great if someone wanted to solve that problem. Things that were great. Yeah, no, pretty much everything else about the project was really great. I'm really happy about how supportive the community has been on Slack whenever I had problems. And if anyone is interested in working on it, there's some really juicy stuff coming up. So these are more ecosystem proposals. Stellar Web Authentication is about using transactions on the network to do authentication with applications. TXRep serialization is about human-readable, compilable forms of transactions rather than XDR byte blobs. You get to read it, compile it, transmit it. Delegated signing URIs is a way for non-wallet applications to be able to express to a wallet application how they want a transaction to be formed and signed without needing to see a private key, so it keeps those non-wallet applications secure. And anchor client interop is a way for wallets to talk with anchors and do some stuff that needs to be done in terms of withdraw and deposit flows, know your customer flows, checking withdrawal history and all that sort of stuff. So all of this stuff is really well-defined and meaty, interesting pieces of work. Speaking about interesting pieces of work and platforms that are driving to improve financial inclusion, let me tell you about Cash App. This is the price you have to pay. It is the #1 payments app in the US, and it is the fastest growing financial brand in the world. This, as I mentioned before, is our new Melbourne office, but we're distributed all over the world and we're hiring quite a bit. We have a lot of exciting projects happening right now. NDA, I can't talk about it. But if you are interested in knowing more about working here, there's a couple of people here that do and can tell you about it. Chris, who I'm sure you all know, is one. And finally, I'd like to say thank you very much for taking the time to listen to my talk. I guess I should ask for questions. That's what people do, right? Yes. Mm.
In general, it depends on how many default parameters you have. So
Right.
in your example, it looked like
Right.
4 parameters. I
Yeah.
don't know if there are a whole bunch of default. That's all there is.
Yep. Yep.
So obviously, it's got 4 parameters and they're all independent of each other. Just use the case class directly. Visible and kind of understandable.
Okay.
As opposed to API there.
Okay. So for the recording, the opinion given is that going back to the case class, instead of a DSL of chained expressions, if there's not many parameters, use the case class because that's straightforward and clear.
Yeah, I mean, the builder pattern, which is the advanced. So the builder pattern works really well in the case where either you've got a whole lot of default parameters that you don't want the user to specify, or possibly not quite defaults, but parameters that can be worked out from the ones you specified, so kind of dependent. So if you've got a lot of dependence there, or if you've got like just lots of defaults and you don't want You just have to figure out which ones to put in, which ones not to put in, then a build dependence useful. Otherwise, keep it simple. I think what you have, yeah.
Makes sense. Thank you. Anyone else? All good? All silent? Sold.